Hello builders, welcome to another video here on Majestic.cloud. My name is Laszlo and today I'm going to talk about some of the essential services that you need to know if you're a developer and want to build modern applications on AWS. Before we start, if you're new to the channel, then please hit the subscribe button. This way you will sometimes see a new and useful video from me on your YouTube homepage. So let's get back to the topic. Often I'm being asked by developers about the AWS services, and one of the most common questions is, what should I start with? After all, there are so many services in AWS, and it's pretty hard for a beginner to know what to start with. In these cases, my answer is most often, it depends. It depends on what you want to do with AWS. Nevertheless, there are some services that everyone needs to know. So in this video, I will help you with some answers on this question, and I will also build an architecture diagram showcasing the services that I will recommend you to start with. So let's start with the basics. There are some essential services that everyone will need to know, no matter what you're going to do. But there are other ones that will depend whether you are a developer, an architect, a network engineer, or a data scientist. In this video, I will assume that you're a developer, and more than that, I'm going to assume that you want to build a modern application based on microservices and in a serverless way. So I'm not going to focus on traditional architectures. I will tell you instead what you need to learn first if you want to build modern applications on AWS. First thing first, you will need an AWS account to get started with. That is obvious. But what if you have it? What service you're going to use first? Well, from my experience, the first thing that you will need to do is to secure that AWS account and decide what kind of permissions you want to grant to the different entities, resources, and so on. You're not going to be able to define these permissions without the IAM service. This stands for Identity and Access Management. You will use this service to create users in your AWS account. These are called IAM users. Then you might want to group your users into user groups. For example, all developers could be grouped into a group called developers, and then you will assign permissions to that group instead of individual users. This will help you a lot if you will have lots of users, because you won't assign permissions individually, but you do it to the group. Then in AWS you have this concept of a role. This role can be assumed either by some user or by some service. For example, an EC2 instance, or a Lambda function. So the permissions that you define on this role will be inherited by the user or the service that assumes this role. Okay, now you have to add the permissions on these entities. And you do that by creating these so-called IAM policies. And these are the things that are attached to your users, groups, and roles, and what you put in this policy will be deciding what permissions those entities will have. You can either create your own IAM policies or use some predefined ones created for you by AWS. So you see that the IAM service is a service that you will use very often every time you need to give or take permissions from an entity. Because of this, I consider this service to be an essential service that you need to know inside out right from the beginning. So let's add it to our application. Then, now you're ready to build your awesome application in the cloud. But how are you going to get visibility into the inner workings of the system? After all, you will have to look at logs, and you will have many different types of logs that you want to check. You could have logs from other AWS services. You could have logs from the application itself. Without looking at logs, you will not get very far whenever you have any issue. Then you will have metrics. Metrics are numeric values that represent different parameters, like the number of requests that your application is receiving, or the number of failed requests. In a traditional environment, this could also be something like the CPU usage of the server or the instance. These are also values that you're going to have to look at from time to time. Then you might need to set up alarms on those metrics. For example, if the number of failed requests goes above a defined threshold, you could trigger an alarm which sends a notification to your email. But you could do even more. You could even start some automation based on those alarms. For example, roll back some code that you deployed and which might be causing all these errors. Now, all these entities, so logs, metrics, and alarms, are part of the CloudWatch service. You will have to work with it often, so you should know this one as well right from the beginning. Now, CloudWatch is essential, but if you build a modern application based on microservices with lots of distributed services, then it's a good idea to get acquainted with traces. Trace will collect all the segments that are generated by a single request as that request travels through the different components of the application. Traces are part of the AWS X-Ray service, so it's a good idea to have an understanding of this as well, especially if you will have a complex application with many distributed components. So we're going to add these to our application as well. Now, the next thing that you might want to do is to upload some data into the cloud. For example, you might want to keep some copies of your important files. Basically, you would be using it as a backup solution. This is a typical use case for cloud, and actually this was the first thing I used AWS for. About 10 years ago, I had to make sure we are storing our backups in a durable and highly available backup solution. So I looked around and found S3 or the simple storage service as a possible solution, and this was the beginning of my cloud journey. But let's get back to the present. So let's imagine you have to store some files. This could be images, CSV files, or any other file that you can think of. You will most likely store them in the S3 service, but you will need to store them in some kind of a container. In S3, this container is called a bucket. This will store all kinds of files that are related in some way. Now there's a lot more to S3 than just objects and buckets, but these are the basic things that you need to know. You will need to learn a bit more about S3 if you're going to work with data. So this is another essential service that we want to have in our application. The next step is to learn about databases, because in your application you will have to store dynamic data somewhere. But which database? AWS has many types of databases. Sure, you could learn a traditional SQL-based relational database, but we assumed in the beginning that you want to build a serverless application. Also, what if you're going to build a very popular application which needs to scale horizontally to extreme sizes. In this case, the best choice in my opinion is DynamoDB. This is a fully managed serverless key value store, a NoSQL database, which allows you to run high performance applications at any scale. DynamoDB organizes data in tables just like any other database system. A table is essentially a collection of data. Then in each table you will have items. This is a group of attributes that is uniquely identifiable among all of the other items. For example, if you have a products table, then each item would be a product. An attribute is a fundamental data element. For example, this could be the color of a particular product. So you see, this is similar to other databases. However, DynamoDB will have its own unique quirks and particularities and scaling options, which you will also need to learn about. So I would learn about DynamoDB if I were a developer who just starts out with the cloud. Okay, let's add this one to our architecture as well. We're going to have a table to store our products. Then, now that we have a place where we can store the data, we would need some compute. Essentially, this would be where our business logic runs and where we can do things with our data. Like, for example, we can process incoming orders from customers, resize pictures, do some automation, and so on. Here again, we are going to look at a serverless compute option, and that will be AWS Lambda. This is a serverless, event-driven compute service, which allows you to run code on demand in any of the supported runtimes. So this could be Node.js, Java, Python, .NET, Go, Ruby, and you could even run some other runtimes with a custom runtime. What you have to do is to package your code as a Lambda function, and then this code would be triggered in response to different actions, like for example an incoming HTTP request. In our architecture here, Lambda would write the order information into the DynamoDB table and start maybe some other processes later. But we are not limited to one Lambda function. We will have many, depending on what task we want to accomplish. For example, we could have another one which creates a CSV and saves it to the S3 bucket. Now you should know that there are many more event sources for Lambda functions. There could be synchronous event sources, asynchronous event sources, and polling event sources. In this last case, Lambda would be polling another service, such as a queue. For each of these different types of invocations, Lambda would have somewhat different behavior. So you would need to learn about these in the first place. So I suggest you learn Lambda inside out, as this is going to be one of the essential services to help you build a modern application. Now, you added some business logic, but you might want to expose this to some outside clients to allow them to interact with your application. For that, you would usually need to create an API. There are many ways to create an API, but in this case, we would want a native AWS solution, which is managed and serverless. So the choice would naturally be API Gateway. This allows us to build a simple or a more complex REST API, depending on your use case, of course. This will expose an endpoint, which is going to act as the front door of our application. All the HTTP requests are going to come into this service, and it will redirect it to the proper integration which could be a Lambda function, but it could be also something else. As the requests are coming in, you are able to modify them, do some transformation, set up throttling, and so on. Also, when the requests are returned to the client from the integration point, you could transform them if you need to. There are lots of things you can do with the API gateway, so you will need to learn this one as well. Okay, now you have an initial application, but you are continuing to add more and more features. Some of these features will need some orchestration. For example, you might want to run tasks in parallel, or you might want to run tasks in sequence. You could try chaining Lambda functions, but that is usually a bad idea, because not only you will incur more costs, but also this kind of chaining is unreliable in many cases and can lead to undesired effects or bugs. The best way to do orchestration is with a service called step functions. This is a workflow service that will allow you to create state machines. These state machines will execute certain steps in the defined order, making it easy to build distributed applications, automate processes, orchestrate microservices, or even run machine learning pipelines. Here in our application, we would use a step functions workflow to process the incoming order. So the user starts the checkout process, and we will use this workflow to validate the card. If the card is valid, we would process the order with a Lambda function. Then we would put the order in the delivery queue, from where another process would pick it up to schedule delivery later. Then we would send a notification through an SNS topic to the user and also end the workflow. Now, if we go back to that valid card choice state, then if the card is not valid, then we can generate an error and then send a notification to the user via an SNS topic as well, and then end the workflow. This is, of course, a very simplified order workflow, just to fit on the screen here. In reality, you would have a more complex workflow, and also orchestration steps could be more complex, but this will help you to reduce your boilerplate code that you would just put in your new code to do orchestration. Instead, you are using step functions for that. So you would have to learn it because it also has additional features not shown here, like, for example, retry logic, manual approvals, task tokens, and so on. So you really have to dig in and learn this service properly in order to be able to use it. So let's add the workflow to our architecture diagram, and let's see what else we need to add. So earlier when I described the workflow, I mentioned a few other services we didn't cover, and it's about time we cover them as well. So first of all, SNS, or the simple notification service. I used it in the architecture to send out notifications to the user. These notifications could be email notifications, but it could be also an SMS text message to the phone or a push notification. Even more, you could send HTTP notifications, so you could send data to a third-party system that has an HTTP endpoint to receive the notification. So for this to work, you have to set up a so-called topic, and that would have subscribers. These subscribers would be then notified every time there is a message for them. SNS can not only be used as a notification service, but also as a way to decouple components and build event-driven applications. So my suggestion is to learn to use SNS as well. Let's add it to the architecture diagram, and then let's see about another way to do integration in applications. So the other service I briefly mentioned earlier was SQS, or the Simple Queue service. This is a fully managed serverless message queue that you can use not only to decouple your components, but to queue actions for later execution. Basically, this allows for asynchronous processing, and it will help in many cases when you don't want to send the request directly to a service, component, or external system in order not to overwhelm it. But you could also use this for error handling as well. If you would send a request directly to a processing backend, but for some reason that backend would be briefly unavailable, then you would have a problem. Instead, you put the data in a form of a message into a queue. And the consumer service can pick up this message from the queue and process it on its own pace. The queue is durable, and if the message is not processed successfully due to errors in the consumer service, then the message would go back to the queue and it can be picked up later by another worker. You can also configure how many times the message should be retried, and if that is exceeded, then the message would be sent to a so-called dead letter queue. So this is SQS in short. Sure, you can come up with many other use cases for this service, so go ahead and learn this one as well, so you know all the particularities of SQS when you're going to need it. You probably heard that event-driven architectures are on the rise, and many people are adopting this type of architecture. In an event-driven system, you will have an event bus that will receive, filter, transform, route, and deliver events. In AWS, this service is called EventBridge. So if you want an example of such an event-driven scenario, then imagine that on your e-commerce platform, the customer successfully placed an order. This new order is basically your event. Now you want to trigger a series of operations. You will send this event to an event bus where you have some rules defined. These rules will define how your events will be routed. They will direct the event to the appropriate target. So let's say you want a rule that listens to this new order event, and whenever it receives it, it will run a Lambda function to update the inventory. Then another rule will listen for some other event, and it will trigger another Lambda function that does something else. For example, it creates a new entry in the CRM system. This is again just a basic example. You can use this service for many other use cases. And I think this service is also essential, especially as this type of architecture gains more and more traction. So we have all these integrations. Let's add event bus to the diagram. And let's cover something else, because one more thing that you need to add to almost any application is authentication and authorization. So you will have to allow users to sign in, and then check what kind of permissions they have in your application. In the AWS cloud, for these kinds of use cases, you would usually use the Cognito service. This provides an identity store that automatically scales to millions of users and has support for social and enterprise identity federation. Now, Cognito has two distinct parts. The first one is user pools. This is essentially a user directory in Cognito. You can use this to sign up and sign in your users. The second big component of Cognito is identity pools, which allows you to create unique identities for your users and federate them with identity providers. This also allows you to retrieve temporary limited AWS credentials to access other AWS services. So I would learn Cognito as well right from the beginning. Now we're almost done, but as you can see, our architecture is pretty complex and we will have lots of services to configure and deploy. Doing this manually is just a pain. Not to mention if you have to do it in multiple environments, such as development, staging, production. Any tiny little mistake in a manual process could derail this whole thing. So to avoid that, always use automated deployment frameworks. In AWS, we have many options. First of all, there is CloudFormation. This will allow you to model, provision, and manage AWS and also third-party resources by treating infrastructure as code. CloudFormation works with templates. These are written either in YAML or JSON, depending on your preference. Then the CloudFormation engine interprets this template and it creates the infrastructure for you. In this screenshot here, you can see the code for creating a basic S3 bucket. But what I would want is to put this whole architecture that you can see here in the diagram into a CloudFormation template and deploy it to all my environments in a safe and repeatable fashion. And with CloudFormation, I can do that. So it's essential that you learn CloudFormation. There are two more options for you, but both are heavily connected to CloudFormation, so it's important to know CloudFormation for these as well, because even if you use these two tools I'm going to mention, you will still from time to time run into CloudFormation. So the first one is AWS SAM, or the Serverless Application Model. This is based on CloudFormation, and it will allow you to simplify the infrastructure code for serverless resources. And also it has a CLI, or a command line interface, that allows you to run some of these services locally. For example, you could run Lambda functions locally, step functions, API gateway, and so on. Then there is the AWS Cloud Development Kit, or CDK, which allows you to write your infrastructure as actual code in one of the supported languages. So CDK supports Python, TypeScript, Java, .NET, and even more. This has the advantage that you can use the same language for your application code and for your infrastructure. Also, you can use object inheritance, loops, and cycles. So you could do lots of code reuse by using the CDK. You could create so-called constructs that you can reuse in your different applications. But this also uses CloudFormation in the background, so your code will be translated to a CloudFormation template. So you see you have these options for automated deployments. So pick your favorite and learn it if you want to automate the deployments and want to avoid lots of headaches. Okay, so these were the services that I consider to be the most important ones if you want to build a modern application on the AWS cloud. Of course, if you build a traditional architecture based on VMs or containers, you would have other services that you need, but you would still need IAM, CloudWatch, and some other services I mentioned. Either way, you will have lots of services to learn, and the learning never stops. So why not have fun while doing it? So, this was my video for today. I hope you liked it. If you did, then click on the like button and subscribe to the channel to get notified whenever there's a new video. See you next time.